powerful than a locomotive, able to leap tall buildings at a single bound. The infant of Krypton is now the Man of Steel, Superman.
But have you ever noticed how Superman's hair never seems to move when he flies through the air? We wanted to find out just how much force that super hair would have to resist in order to stay in that picture-perfect curl through so much wind speed. To simplify the problem, we won't even think about that one time Superman flew so fast he reversed the Earth's rotation and somehow turned back time. We'll consider 3 possible flight speeds: that of a speeding bullet, that of a bird, and that of a plane. We'll assume Superman travels at constant velocity and altitude, and we'll consider this to be an altitude where the air itself is almost stationary, but there is still enough air molecules to exert drag force on Superman. So, what is drag force? Drag force is the force that a fluid, like air, exerts on a solid, like Superman's hair. Now that we have our problem set up and our assumptions, let's consider the equation for drag force. Since the dimensions of Superman's head are not changing, we'll consider the drag coefficient term and the area term to be one constant, which we'll call k. To determine k, we'll need to conduct an experiment. For our experiment, we'll need a few things. First of all, a wig, a wind tunnel, and a force sensor. We'll place the wig into a wind tunnel and blow it around at different air speeds. At each speed, we'll measure the force that the hair experiences. Remember, we will assume drag force is the only force the wig experiences. We'll then plug the force value and air velocity back into our drag equation and solve for the constant k. Once we have k, we can simply insert values for airspeed, v, into the equation and solve for the drag force that the hair would experience at that flight speed. If Superman flew at the speed of a bird, his hair would experience a drag force of about 18 newtons. At the speed of a plane, his hair would experience a 3,000 newton drag force. And finally, if he flies at the speed of a bullet, Superman's hair will experience a drag force close to 80,000 newtons. Must be some super hair gel. Thanks for watching our video on the fluid mechanics of Superman's hair. Now, up, up, and away!